Welcome to this video tutorial. Today we will learn superposition theorem. Superposition theorem states that in a linear network with several sources, the overall response at any point in the network is equal to the sum of individual response of each source considered separately, the other sources being made inoperative. So basically, there must be several sources present in the network. That time we will apply the superposition theorem. Another statement, we can say that in a linear network containing two or more independent sources, the voltage across or current through any branch is algebraic sum of individual voltages or currents produced by each independent source being acting separately with all the other independent source set equal to 0. Here we can see one question that we have to find out the current through 23 ohm resistor using superposition theorem. In these questions, we can see there are two sources, one voltage source and one current source are present. Now we will solve this problem. So we will do it step by step. So step 1, we'll redraw the circuit and we'll use one source at a time. So we are using 200 volt source and we'll replace the current source by open circuit. And then we will find the equivalent resistance and accordingly we'll find out current for 200 volt source. Just remember, when voltage source is present, if you want to replace it, you have to make it short circuit. When current source is there, you have to make it open circuit. Then what will be the equivalent resistance? Equivalent resistance of these circuits. Find out the equivalent resistance. (27) and we can see 47 and this 4 plus 23. So can I write 47 plus? See, current is going through this path, some current is through this path and some current is through this path. That means 27 is parallel to 27.
47 plus 23.
27, no, 47 plus this. This is 4 and this one is in series, as this one is open circuited. So 23 plus 4 is parallel to 27 ohms plus 47 ohm will be the total equivalent resistance. This is 47 plus 27 into 27 by 27 plus 27. This is 54. So this is
the calculating part, ma'am. Exact value is 60.5 total value.
Exactly. 47 plus 13.5 is equal to 60.5 ohms. Now what will be the current? That is total current through it. This total current is equal to current flowing from this source will be 200 volt by 60.5. Just calculate it.
Ma'am, that's 3.3.
3.31. Now we have to find out current through the 23 ohms. So this current is I dash 23. So I dash 23 ohms is equal to, now some part of the current is flowing through this path. When the resistances are connected in parallel, current in the branch is equal to main current into opposite resistance by sum of resistances. Try to remember this one. We have explained it already. Neha?
Yes, ma'am.
Is there any doubt in current divider rule? The main current, that means I total, this current will flow up to this. Then we can see the branching. So main current is I total into opposite resistance. Our objective to find out this current through 4 ohms and current through through 23 will be same. The same current will flow through this path, that because they are connected in series. Now some part will flow through this part. So this is the opposite resistance. Main current into opposite resistance by sum of resistances. Sum of resistances means 27 plus 4 plus 23. So this is 3.31 into opposite resistance. That is, this is again 54. So this is 3.31 by 2. Now what is the value? What is the value?
1.65.
1.65. 1.65 is the current flowing through this 23 ohm resistor for this 200 volt source. Now we have to find out current when the current source 20 ampere source is present only. Again, I'm redraw the circuit. I have to redraw the circuits. So now this is 27 and this is my 47 ohms and this path is short circuit. After that, there is 4 ohms. This is my 23 ohms. And in between, a current source of 20 ampere. This is 23 ohms. This is 4 ohms. Now, in this circuit, say, this 47 and 27, they are connected parallel, right?
Yes, ma'am.
They are connected parallel. Then this one will be in series with 4 ohms. Now if you draw again the circuit, it will be single resistance, that is 27 parallel 47 plus 4 ohms. And this is the current 20 ampere. And this is your 23 ohms resistance. Now you have to find out these values. Again, this will be, what is the value of equivalent, this equivalent resistance? This equivalent resistance, (27 into 47 by)
21.15.
Okay.
Equivalent resistance.
Exactly. In this, by this 27 plus 47 plus 4. So this is equal to 21.15 ohms. So if you want to redraw the circuit, it will be, always try to draw this type of circuits. Then your conception will be clear. There will be one single resistance, this is 21.5 ohms, and one current source, another 23 ohms. So now I will find this I double dash 23 ohm current through this. So this I 23 double dash is equal to, now opposite resistance is this one, 21.5, by sum of this resistance. Yes?
Ma'am, that is 21.15.
21.15, right. This is 21.15. 21.15 plus 23. This is the resistance part, no? Opposite resistance by sum of resistances into main current. Main current is 20 ampere. Just calculate this one. What is the value?
9.58.
Okay, 9.58 ampere. So this is the current. This is the current flowing through 23 ohms when only 20 ampere current source is active. So total current now the total current flowing through 23 ohms resistor when both sources are present. It is the algebraic sum, right? So this current is equal to I23 single dash plus I23 double dash. So previously this current was 1.65, 1.65 plus 9.58. So this one is equal to how much?
11.23.
11.23. Now I think this concept of superposition theorem is clear.
Yes, ma'am.
We have to use,
Yes, ma'am.
we have to use one source at a time.